Science Friday. My name is Ariel Zich. I'm Science Friday's Education Director, and I'm here today to talk with Dr. Katie Stack Morgan. Katie Stack Morgan is a research scientist at NASA's Jet Propulsion Laboratory and a deputy project scientist of the Mars 2020 rover mission. She is using images and data from the Perseverance rover's experiments on rocks to hunt for evidence of life on Mars. And Katie, you're going to take our audience's questions today. Is that right?
Yes, that's right. And thanks so much for having me. I'm really excited to be here and to hear these great questions and hopefully answer them as well.
Oh, that is wonderful to hear. Thank you. Yeah, and so we're going to get cracking right to it, but I want to kind of set the stage for everyone. I was hoping, Katie, that you could tell us just a little bit about what your role is at NASA Jet Propulsion Laboratory and why that's so exciting.
Yes, I'm a research scientist at JPL. And I am the Deputy Project Scientist of the Mars 2020 Perseverance rover mission. I'm one of the scientists that helps to lead a team of over 500 scientists from around the world who operate the rover on Mars right now. And so it's my job to help lead that science team and help get the team to make decisions about how we should operate and what science observations we should make with the rover on Mars.
Now, we've had rovers on Mars before. What is so exciting about Perseverance?
Yes, Perseverance is really special because it is the first mission in a potential Mars sample return effort. So that means we're trying to get samples from Mars back to Earth, and it's Perseverance's job to collect those samples. And those samples in the future, we hope to hand off to a series of other missions that will bring them back. But Perseverance is really the first step in this. And so Perseverance's job and our job as scientists is to command the rover to drive around Mars, selecting the best samples on the surface of Mars that can tell us the answers to big questions like, was there ever life on Mars? And how did the planet evolve over time? So it's our job to select these samples and Perseverance's job to collect them and in the future, pass them off to the next mission.
Well, that's outstanding. And it's neat to think about your mission touching the lives of so many scientists in the future. It's this idea that you're participating in this legacy that's going to last for years. I know that you look at a lot of pictures of Mars every day, and I think that's going to get us to our first question. So Kaylin, age 11, has an outstanding question about what it might look like if you were standing on Mars. So Kaylin, you are being invited to unmute yourself. Oh, I will, oh, it looks like Kaylin can't come on, so I will ask Kaylin's question. So Kaylin, age 11, wants to know, what would it look like if you were sitting on Mars right now?
That is a great question, and thank you, Kaylin, for that question. Actually, Diana, if you could pull up slide 4 that I have, I can show you what it looks like on Mars from the rover's view right now. Okay, so what you all are looking at is an image taken by the Perseverance rover just a couple of months ago. And this is taken with one of the cameras on the rover. And these cameras act as the eyes of the rover. So they're what help us, think about as scientists, what it would be like if we were standing on Mars ourselves. And so this is one of the views that we had. And so first thing you might notice in an image like this is that everything is tinged kind of red, especially compared to what we have here on Earth. Everything is very dusty on Mars, and the dust on Mars is red. It's why we call Mars the red planet. And so what you can see in the background of this image is a mountain. We think this is actually an example of a mountain made of ancient lake deposits, which is one of the things that Perseverance is on Mars to go check out. But what you can see in the foreground of the image are some big, massive, dark rocks. And there are a lot of rocks on Mars, and it's one of the reasons why we get so excited about Mars as geologists. And you can see those are big and dark. And rocks on Mars tend to be sometimes darker and more red than rocks here on Earth, at least some of the rocks on Earth. And so this kind of barren but rocky landscape is very typical for Mars with that reddish glow about it. And so this is what you would see right now if you were standing on the surface of Mars right next to the Perseverance rover.
That is an awesome image. Thank you for sharing that with us, Katie. You mentioned that you were interested in these sort of ancient lake beds. Why is that? Why are those the sort of target of your mission at this time?
Yeah, Perseverance is looking for signs of ancient life on Mars. And so we're looking for environments to explore that might have evidence of this ancient life. And one of the places that we find ancient life here on Earth are ancient lake deposits. And so we're looking for ancient lake deposits on Mars with the idea that maybe if we have life in ancient lake deposits here on Earth, we could find similar signs on Mars. And life likes water, it needs water to live. And so going to a place on Mars that once had a lot of water is one of the first things we think about when we're looking for signs of ancient life. Lakes are also really good at preserving signs of life, which is important because the life we're looking at or looking for on Mars would be billions of years old. So we also need it to be preserved in the rocks. And so lakes are a great place to do that too.
And that is a question that's very, that you've almost answered for Gia. So Gia, age 9, has a question about kind of even the chemistry of what you're looking for life on Mars. Gia, would you like to unmute yourself and ask your question?
Yeah. So, what are the elements needed for life to survive on Mars?
Yeah, thanks, Gia. That is a great question. You might have heard of something called schnapps, which is kind of a funny word, but it's an acronym for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And those are the kind of group of elements, and I know I said that really quickly, but those are the group of elements that we think are really the building blocks for life, in particular, carbon and hydrogen. And so many of our organic molecules that make up life here on Earth and that we think could have made up life on Mars if it ever existed are things that might have carbon and hydrogen in them. And so those are the elements that we look for, but that whole range of elements are the elements that we think are most important as the building blocks of life. Thanks so much for your question.
There are so many good questions, folks. I cannot wait to get through all of them, but we're going to do our best. So getting right to it, you mentioned that you're looking for ancient life on Mars. Presumably that's in the form of fossils. So Jasper, age 12, has a question about whether or not we have fossils on Mars. Jasper, are you ready to ask your question?
Are there fossils that show evidence of life on Mars?
Yeah, Jasper, that is a great question, and we sure hope so. Sometimes we joke about finding a dinosaur bone on Mars, but that's kind of in our wishful thinking. What we think, we know that Mars took a very different path than life here on Earth. Life on Earth developed into very complex life forms like dinosaurs or ourselves even. On Mars, we think things didn't perhaps progress quite that far. So we think that if there was life on ancient Mars, it was probably at the microbe stage and possibly never got beyond that in terms of how complex life could develop. So the kinds of signs of life that we're looking for on Mars are probably signs of microbial life. But that could still mean that there may be fossils, but it'll be perhaps not fossils that aren't quite as obvious as a dinosaur bone or a shell imprint. But it could be textures in the rock that are not normal or that wouldn't form if life wasn't present, or a distribution of elements or minerals or organic matter that again wouldn't form if life wasn't there using those minerals and elements and producing those organic molecules. So we're looking for more subtle signs of life, but we're still hopeful that those signs would be preserved in the rock record, therefore making them fossils. We haven't found them quite yet, but that's one of the reasons that Perseverance is on Mars exploring today.
Now, we've got a number of questions about the equipment you're using to explore Mars. So it's the rover itself is a package of a lot of different things in it. Is that right?
That's right. Yep. We have a lot of different science instruments and some really exciting technology on the rover as well.
So Elias has a question about some of that technology. Elias, do you want to ask your question about the science lab on Perseverance?
I think that Elias had to leave, unfortunately. Ariel, would you mind asking their question for them?
Sure. How does Moxie change carbon dioxide into oxygen? This is a really specific question. I also want to know why.
Yes, well, thanks, Elias. That is a great question. One of the really exciting technology demonstrations that we have on the Perseverance rover is the Moxie instrument. And Moxie is on the rover to help us prepare for future human exploration of Mars. And one of the things that we think humans are going to need on the surface of Mars is oxygen, because there isn't a lot of oxygen there already. Most of the Martian atmosphere is made of carbon dioxide. And humans would need oxygen on the surface of Mars for a couple of different things, simply just to breathe. So that would be an important thing. So creating a habitable environment for humans, but also one of the most important reasons we would need to make oxygen is to contribute to rocket fuel that would get humans back to Earth after they were done with Mars. And rocket fuel is heavy and expensive, so you don't necessarily want to bring it with you. You want to be able to make it there. And of course, carbon dioxide is abundant on Mars. So how Moxie works is it basically takes the CO2 into the instrument, and then it runs electricity through the carbon dioxide molecule, separating the carbon from the O2, the oxygen. And it's basically a fuel cell run in reverse, if folks know what that looks like. And so once we run the electricity through that molecule and split it up, then we've created the carbon and we've created the oxygen, and then we can release the oxygen back into the atmosphere. And so in the future, we might take an instrument like Moxie, scale it up much bigger, and be able to capture and harness that oxygen for breathing or for fuel. And so that's how Moxie works, is by using electricity to split up molecules.
That is incredibly cool. And so you've got all of these different instruments on board. Allison has a very practical question about that rover. Allison, would you like to ask your question? Go ahead and unmute yourself if you're able.
Hi, I'm with a class of students, and one of them wanted to know how heavy the rover was, how many pounds it was.
That is a great question. And actually, I don't think I know exactly how heavy it is myself. I think I've heard that it is, well, so I'll give you this, and maybe this will help. But the rover itself is about the size of a small car. And so you can think about, if you can think about how heavy it might be to try to lift up a small car, that's probably about what it would take to try to lift up the rover. So it's quite heavy. I want to say something like, close to, I'm not even going to guess on that one. I'll have to look that up. But that's a great question. And you can think about it about the size and weight of a small car.
And we've got a question kind of related to that, actually, which is a question about the sky crane. So Robert, we're very interested in your sky crane question when you're ready.
Hello. So will the sky crane mechanism work for a future manned Mars roving vehicle like it did with the Perseverance?
Yes, that is a great question. Thanks for that question. So one of the reasons why NASA transitioned to using the sky crane method of landing on Mars, and for folks who are not familiar with how Curiosity and Perseverance landed, there was actually basically a rocket platform that had a series of cables that then the rover descended on. The cables were cut, and then that descent stage flew away after gently landing the rovers on the surface of Mars. And both Curiosity and Perseverance used that method to get to the surface of Mars. And this was different from earlier smaller rovers. The Mars exploration rover Spirit and Opportunity had these big inflatable airbag balls where they basically bounced on the surface of Mars until they came to a rest, and then they opened up. But the idea being that if we want to think about delivering heavier and heavier payloads to the surface of Mars, including humans in the future, we needed to move away from just bouncing airbags to something that could actually deliver something heavier to the surface. And that's where the sky crane technology came in. So that was one of our reasons for developing that technology and testing it out with the rovers. And so we do anticipate that that kind of technology could be used in the future. But there's also a couple of other things that NASA is working on to deliver even heavier payloads. And I think an exciting part of Mars Sample Return is actually testing a new part of that, which is the Mars Ascent Vehicle. So we've blasted things off the surface of the moon before, but with Mars Sample Return, one of the ways we would get samples from Mars back to Earth is by putting them on a Mars Ascent Vehicle and blasting them up the other direction. So NASA's got a lot of different technologies in play right now to both get things to the surface of Mars and to get them off of it. And so those are things that are still in work. But yes, the sky crane technology is something that we anticipate using in the future for heavier and heavier payloads.
And that sky crane wasn't the only fancy new technology you had aboard. I know we've got a question about Ingenuity, which I'm sure you were prepared for. Robert, would you unmute yourself and ask your Ingenuity question?
Okay, are there any more scheduled flights for the Ingenuity Mars chopper?
Yes, that's a great question. And actually, if we can bring up slide 2 first, and then maybe we'll transition to, okay, yeah, we can start here too. So yes, this is for folks who don't know, along with the rover, the Perseverance rover, there was also a buddy going along with the rover for the very first time, and this is the Ingenuity Helicopter. And so this is a little video of what we're looking at. It's a video of the Ingenuity Helicopter on one of its early flights, where it basically went up and then down, and the camera on one of the cameras on Perseverance rover captured this flight going up and down. And this is one of the coolest images and series of images that we have from the rover so far. And Diana, if we can go to slide 2 as well, that's another view where we have, you may have heard that Perseverance and Curiosity as well, they take selfies. And this is one of my favorite selfies we've ever taken with a rover, where we have Perseverance taking a quick look to the side at Ingenuity there in the background. So Ingenuity was another technology demonstration on this mission. And it was originally slated for about 5 flights, and it did various testing. First, the flights were quite simple. They would go up and then down and then up and then over, and then flying longer and longer distances. And after Ingenuity completed its initial phase of its mission, we decided to keep it operating because it was still healthy, still ready to go. And so now we're in the next phase of the Ingenuity mission, where it is kind of acting as a scout for the Perseverance rover and flying ahead of the area that Perseverance is going to drive, and taking pictures that inform us of what's to come in the future. And so we are planning to, so Perseverance Ingenuity has continued to do its flights, and we actually have another flight planned for just a week or 2 from now. And we'll probably continue to fly Ingenuity for as long as it is healthy and able to go. It wasn't really built to be quite as sturdy as the rover itself. So in some ways it's living on borrowed time, but we'll continue to operate it for as long as it makes sense to do so. And it's providing great images from the surface of Mars for us.
And as we look around Mars, we've got some questions kind of more about those, specifically about the samples you're collecting and how you decide about those samples. So let's start with Griffin's question. Griffin, age 9, has a question about rocks that we're collecting on Mars. Go ahead and ask your question. So we aren't quite able to hear you, Griffin. You're sounding very quiet. So I will ask your question for you. Griffin wanted to know, how big are the samples that you are collecting?
Yeah, Griffin, thank you. That's a great question. They are about the size of your pinky. The mass of the samples is that of a golf ball. So you can think about a golf ball, but stretched into kind of a pinky or a pencil shape. And that's what the samples are. And there a lot of thought went into how big the sample should be, both from a science perspective and from an engineering perspective, keeping in mind that we want to get these samples back to Earth, so they can't be too heavy, because the technology we developed to bring them back has to be able to carry that mass of rock sample back to Earth. But we also wanted to think about how much rock did we need to do the kind of scientific analysis on these samples that we need to when they come back. So there's a lot of thought that went into how big these samples should be. And scientists decided that about the size of a golf ball, or in the shape of a pencil, was about what would allow us to accomplish the goals, the science goals we have when those samples come back to Earth. Thanks so much for your question.
And on that note, so let's say you've got some samples. Lucille wants to know then about communicating with Perseverance about those samples. So Lucille, age 7, go ahead and share your question when you're ready.
How do samples get back to Earth from Mars?
Yes, thanks, Lucille. That is a great question, and something that NASA is working on right now. So Perseverance's job is to collect rock and soil samples and store them in little tubes, and leave them on the surface of Mars, or potentially pass them off to the next rover that we call a fetch rover. Just like your dog would fetch something, this rover would fetch the samples that Perseverance collects. Then the next leg of that mission would involve taking those samples and blasting them off the surface of Mars. But then that rocket that would blast off the surface of Mars has to rendezvous and meet up with another orbiter that would be circling Mars. And so we transfer the samples from the surface of Mars to an orbiter that would then fly through space back to Earth, and then go through the Earth atmosphere and land those samples back on the surface of Earth. So the way that we would get samples from Mars to Earth is through a series of different missions. So it's not all Perseverance's job, but a series of missions, rovers to orbiters, to get those samples back. So it's a pretty complex series of maneuvers we have to pull off. But each one, NASA's done before. We just have to string them all together and hope that the timing is just right and gets those samples back to Earth.
Neat question. And we've got another question that's specifically about samples. And I'll just say, just a quick reminder that this is Science Friday from WNYC Studios. We're talking about Mars with Dr. Katie Stack Morgan. One of our last questions, Leo, age 8, has a question about where else we might look for life on Mars. So you've mentioned some of the surface samples. Leo, would you like to ask your question? Oh, here comes Leah.
Mama. Will we look underground?
Leo, thanks for that question. That is a really relevant question that the scientists who are studying Mars are asking themselves and asked themselves when we were trying to decide which landing site to send the rover to for Perseverance. And so the kind of life that we're looking for, the signs of life that Perseverance is looking for, is very ancient life. Could be, billions and billions of years ago was when it was actually alive on the surface of Mars. But we know today that, and part of the reason we look way back in time is because the surface of Mars today is not a habitable environment. Life as we know it really couldn't survive at the surface of Mars today. But that doesn't necessarily mean that life couldn't exist elsewhere on Mars today. And so this is a really interesting question, because there could be very small places on Mars, and maybe they're underground, where there are places where life could exist. And so there's talk of what we call a subsurface biosphere, or an area underground where life could actually exist today on Mars. But I think this is where it gets tough. Drilling into the surface of another planet is a hard thing to do. It's hard on Earth, and it's especially hard to do it on another planet. And you can imagine it would take a pretty big drill to drill deep enough into the surface of Mars to get to an area that might be shielded from the radiation that the surface of Mars experiences today. And so we would love to drill deep into the surface of Mars for a number of reasons. But we're not quite ready to do that. Although I know at JPL, I know a couple of folks who are working on just that question. So it could be something that we're able to do in the future. But for now, we take advantage of the fact that there are rocks at the surface of Mars that were once deep underground, but are now exposed at the surface. And so we kind of use Mars and impact craters to do that job for us by bringing the rocks that were once underground to the surface for us. So we take advantage of that, and we don't have to drill down too deep to actually get the rocks that we're looking for. But there's a possibility that life could exist in the subsurface of Mars. And maybe in the future, we'll have the technology to check that out. So that was a great question and a great way to think ahead to the future of what might be possible for planetary exploration.
All right, now I know we're about at time, but we have one last awesome question. So we're gonna do one more question. Gia, age 9, has a question about Perseverance's ability to stay clean on Mars with all of this digging. Gia, go ahead and ask your question.
Yeah, so how does Perseverance dust itself off if it can?
That is a great question. And the answer is Perseverance does not dust itself off. And it's really interesting. And I think the best experience we have is with Curiosity. When the rovers first land on Mars, they're looking pretty sparkly clean. But over the years, and Curiosity has been on the surface of Mars now for over 9 years, things get pretty dusty. And so when we take images of the deck of the rover, we can see how dusty it gets over time. But that's okay, because Curiosity and also Perseverance actually don't use solar power. So previous smaller rovers like Spirit and Opportunity had solar panels. And so those solar panels got dusty and would need to be cleaned off intermittently. And the way that that happened for Spirit and Opportunity was actually with dust devils. Very, fortuitously, opportunistically, dust devils would move across those solar panels to clean them off for the rovers. But with Curiosity and Perseverance, they have a nuclear power source. So even when it's really, really dusty, and when the rovers get really dusty, it doesn't so much matter, because they can still generate the power that they need to operate. But I will mention a really neat thing that Perseverance has. It has a tool to do dust clearing, not of the rover itself, but of dust that we have on the ground. So when Perseverance drills or creates has a tool that can abrade the surface of the rock, remove the surface of the rock, it creates a bunch of fine dust. And so then we have basically a little gas puffer that goes and can actually blow that dust away. And we call it the gas dust removal tool. And it can actually blow dust off the surface of Mars, and it makes a little clean area on the surface. And so we won't use that tool necessarily on the rover itself, but we do have a way to clear dust. It's just on the ground instead.
That is so neat. You've answered a few other questions too. Mac, Rosanna, and Harshit, I think, have had some of their questions answered, which is really helpful, because you addressed so many facets of dust on Mars in that one answer. I want to thank you, Katie, for coming on to Science Friday today and answering so many of our audience's questions. Thank you all for your wonderful questions you submitted. Thanks for joining us, everyone. We had a great time. And again, this is Science Friday. We've been talking with Dr. Katie Stack-Morgan about Mars 2020, and we are so grateful to have had you. Thank you, Katie.
Thank you so much for having me, and thanks all for dialing in and for those amazing questions. Keep asking those questions.